Oh, so in this lecture, we are going to start chapter 10 regarding nested types. So in this nested types, we are going to discuss like inner class and anonymous classes, nested class, local classes, anonymous classes, and lambda expression. Okay, so those four are the major topics that we are going to discuss in our lecture in this chapter. Okay, so first let's take a look at the relationship so far we have discussed between classes. Okay, the first we discuss is aggregation that has a relationship. And the second one we already discussed is about inheritance relationship. So is a relationship. And the third one we discuss is between classes and interface. Okay. So it's a realization, but it still is a relationship. So those are the relationships that we have discussed in previous chapters, okay, between different classes. And in this chapter, we are going to discuss a new relationship. It's about a nested class, okay? So for nested class, then it has the corresponding outer class, okay? So what it is. So the relationship is a nested relationship. So what is it? How it looks like? Okay, how do we create? So the syntax to define a nested class is, so here is the outer class, as usual, the outer class, okay. And it has visibility, the class name, okay. And then within its definition, we can define another class. Within it, it's outside. Within it, we can define another class as usual with keyword class and class name and visibility, static or not. Okay, and then plus like the fields and the methods. So that's the syntax for the definition of a nested class. Okay, then let's see what is then a nested class. Okay, so the full name of a nested class basically should also include the outer class, then dot, and then the nested class. So that's a complete name. There are two different types, okay, non-static and static. Okay, and there is some difference between these two types. Okay, for non-static nested class, they are also referred to as inner classes. Okay, inner class, so keep that in mind. But because it's nested, it's non-static, so because class can be used to create instance, but that's not always the case. Okay, if you recall abstract class, you cannot use abstract class to create objects. So, but for inner class, non-static nested class, it can still be used to create an instance. Okay, but it must be associated with an instance of the outer class. So we need to be careful here. Okay, an instance of the outer class. So it's not like a static class. Okay, uh, just the class itself. But here it must be associated with an instance, okay? And it can access all the outer class fields and methods, even they are private. And also, so this is two-way, outer class can also access all the inner class fields and methods, including private, okay? And but for non-static nested class, you cannot define any static member, so it doesn't accept a static member. So that's a major difference, okay? between a nested class and a regular class. So you cannot define any static members. And it can access two-way, okay? Nested class can access outer class fields and methods, and outer class can also access inner class fields and methods. The second type is a static nested class. So you must have the static keyword, okay? And for this, it can only access static members of outer class. So now static cannot be, so instance variable cannot be accessed. Yeah, but based on the name, we can also kind of have the idea instance variable. So it's associated with an instance of the class, okay? And also to belong to the entire outer class type, not like the non-static inner class. Okay, it belongs to an instance of the outer class. So this belongs to the entire outer class. Okay, yeah, this static nested allows to define static members. So this is the concept about a nested class. And remember, it has two types, okay, inner class and a static nested class. So the core concept for nested class is a class that's defined inside another class, okay? When to use a nested class is that when you want to fully access all members of the nested and outer class. It has better preserve encapsulation of the outer class's members. Okay. And encapsulation, if you recall previously, it's achieved through the keyword of private. Okay. But with the concept of nested class, basically it also provide certain level of encapsulation, okay, for outer classes members. Yeah, it can better preserve. It also clarify ownership concept because nested class belong to the outer class. Okay, then let's compare the difference between the non-static, the inner class, and the static nested class. Okay, so the header has a difference is for the static one has a keyword static. And the relationship to outer class is for inner class, it belongs to the instance of the outer class, while the static one belongs to the outer class, entire outer class, okay? Can access outer class instance variable? Yeah, for inner class, yes. But for static, it's no, okay? Access outer class static, yes, for both. Okay, outer class can access its instance members. For inner class, yes. And for static, it's also yes, okay? Outer class can access its static because for inner class doesn't allow to define static members, so then you cannot, is it? Yeah, for static, yeah, it's yes. So that's the difference between these two types of nested class. Okay, so the above discussion is about nested class. So it's a class defined inside another class. Okay. We have a second concept in this chapter. It's called local class. So what is this? Okay. So far we learned local concept. It's a local variable, is it? Yeah, we have this concept. So we kind of understand for local variable, the concept is a variable defined within some brackets. Okay, so similar concept. Local class is some class you defined within a block. Let's create a local class. So here is some program block. Then within it, you define the class. You have the class and the class name, and then the fields and methods. Okay. So the block can be a method, can be loop, can be condition. Okay, so then the definition about local class, what is a local class? So it's some special type and it's non-static inner class, okay? And it belongs to an instance. Also, it belongs to an instance of the outer class because in Java, everything is in a class, okay? And it cannot define any static members. Okay, but it allows static constants. Okay, so static final. Okay, something. Yeah, that's allowed. Allowed to create a local class. It is allowed to create a local class within a static method. So this is allowed or block. Okay, and then this local class nested within the static block would only be access static members of the outer class. So if it is this case, then only access static part of the outer class. So local class different from nested class. It doesn't allow entire local class to be static because if you do want it, then you better have static class defined as private static class instead. Okay. So that's a general concept about local class. And what's more for local class, then you may say, oh, then do we allow to have local interface? Yeah, it's not allowed. Okay. And the local class only valid within the scope of its enclosing block. So be careful. Okay. Just like local variable concept. Okay. So that's regarding its scope. Okay. So local class, it's one class defined inside a block, okay? And it must be a concrete class. And like previous, we said local interface not allowed. And also it cannot be a static one. It must be non-static, okay? Cannot define any static members. But that's not the case for constants. Okay, so static final for constant, that's allowed. So when do we use a local class? And sometimes we want to use it within a block to use some class. Then you can do it, okay? And you need full access of the members of the outer block. Also full access to the local variables of the outer block. Okay, so that's all regarding just the outer block. In those cases, then you create a local class, and it's a one-time class. Okay, you cannot repeatedly use it. Okay, so for a shorter break from our concept discussion. So this is a national park that I have visited, quite a famous one. Okay, so here's another picture from that national park. So what is it is? What is this national park? Think about it. Okay, then let's continue. Okay, and the third concept in this chapter is about anonymous class. So what is this? Okay, so so far, all of the class we have learned has name, but yeah, sometimes you can create a class, define a class that doesn't have name. Yeah. So then it's unnamed local class. Okay. That's anonymous class. So the syntax to define an anonymous class, basically it's generally speaking, a lot of time we use it within some block. So it's kind of like the local class. Okay. So it's like over here. So some variable is it in the type in some interface. Then you do the new and the interface. So this looks like a constructor, is it? So create some object. But be careful, that's not, you can directly use interface to create object because over here we kind of omit uh, uh, a lot of statements, okay, like you define class, is it, and then you use constructor to create a class, to create objects. Create object, okay. When you define class, because this class implements some interface. So basically, this means you define some class that implements some interface, okay? And then within it, that class also need to have constructors, some methods. As we can just basically skip all the like constructor and go directly to the implement the abstract methods of the interface, okay? You can also define the class fields and methods within the implementation, okay, then semicolon here. So it's so basically this class doesn't have a name, and so we didn't define the class. Okay, we just directly kind of go ahead to use the class to create objects. But within it, you still define the fields and the methods. Okay. Yeah, so this is the concept syntax about anonymous class. So it's kind of you just omit some statements for the regular way. Okay. Okay, so what is anonymous class? Then it's defined and also instantiated. Okay, at the same time. Okay, so that's anonymous. Anonymous class doesn't have name. No name, okay? So it's not like a local class, which is declared according to the normal class, the header and the rules, is it? So anonymous class, it's kind of just a part of an expression. So if you recall, remember, it's just have the new and the interface name and the parenthesis and then the block. So more like an expression, okay? And so it defines the instance at the same as part of an expression. Okay, it implements an interface or extends a class. That's normal scenario. Okay, when we use anonymous class, implements an interface. That's mostly used. Okay, you can also, of course, it extends from a class. Okay. When to use it, just like a local class, you only use it once. Okay. And in that case, then you can go ahead to use anonymous class. Okay, so we already see anonymous class is already kind of concise as compared with the regular local class. Because regular local class needed to have the regular class name and the header. But for anonymous, you don't need to have class name and header, etc., because it's involves directly involves new and the kind of call constructors. So it's instantiated. So it's defined and instantiated at the same time. Okay. But even with this, um, sometimes with some special interface. Okay, because for anonymous class, most of the time we use it as the class going to implement some interface. And there is a special type of interface. That interface has only a single abstract method. Yeah, we call it a SAM. Okay, and this kind of interface, we call it a functional interface. This doesn't mean that it only allows one method, it only has a single abstract method, but it can have many default methods and also static method. Those are allowed, okay, but not just one abstract method, okay. And so we can create anonymous class from a functional interface. Yeah, no doubt. Okay, because anonymous class can be created from any interface. Okay, and but with this kind of special functional interface or SAM, okay, we have an even more concise option to define and implement it. We call it a lambda expression. Yeah. So this is very cool. Okay. So it's very concise way to program. Okay. Called lambda expression. So it looks like just like a method definition. Okay. Looks like a method, but no. Okay. It serves to create an instance of certain type. So be careful, okay? It's still create some objects. Where on heap, is it? Yeah, so the syntax to write lambda expression. So be careful, even though it's called lambda expression, it's not just expression, okay? It to create an instance of some type. There are different types, okay? If functionals interface that single abstract method just has a single parameter, then you just provide a parameter and then arrow and then block to implement that method. So basically here is to implement that abstract method. Okay, the implementation. So the focus is on, the concentration is on the implementation. Okay. So that's we emphasize the implementation part. Okay. And we can also have, if the method has a list of parameters, then you need to have the parenthesis and list the parameters. And then still the arrow is must and the brackets, okay, it's a must. And the implementation here, okay. That implementation is regarding that abstract method. And if you just, so if your code is very simple, okay, we can just write like this, okay, the parameter and then arrow and then expression. So we even don't need the curly brackets. So this is about lambda expression. So it's more concise compared with anonymous class. Okay. So if you have anonymous class that implements functional interface, then you can go ahead and use lambda expression. Okay. So it's more concise. So lambda expression previously we already saw is that basically it has three major parts. The parameter or parameter list, okay, from that single abstract method of the functional interface. Be careful, okay, lambda expression only applies to functional interface. This is a must. What is a functional interface? Meet a single abstract method definition. Okay. And if the uh, method abstract has only a single parameter, we can even omit the parentheses. Okay. The second part is the right pointing arrow, right arrow, and then the code block. Okay, so that's lambda expressions, three major parts. Okay, so the definition for lambda expression is similar as anonymous class. Okay, so it's implement and instantiate an object, but this time it's from a functional interface. Okay. And when to use lambda expression is if you want to your code with anonymous class more concise. Okay, then you can choose the lambda expression. Okay, so that's the lambda expression. So this chapter, in this lecture, we discussed four concepts. Okay, nested class, then move to local class. And for nested class, there are two types. Okay, non-static versus static, and then local class, and then anonymous class, and then lambda expression. Okay, then let's see. We discussed the nested relationship in this chapter. So let's have a summarize. So this is regular class, the outer class. Okay. Then we have two different type of nested class, inner class and the static nested class, is it? And when we want to have nested or inner classes, we want bidirectional full access to all members. Okay, then you can design nested class. For inner class, if you need access to instance variable, okay, and if you only need to access static, then you define static nested class, okay? And if you only want to use a class within a block for once, then you can have a local class, okay, in a block. And if you want to only use once and define instance at the same time, then we can do anonymous class, okay? And if the anonymous class implements a functional interface, then we can use a lambda expression, okay? So this is the most concise implementation, okay, regarding the nested relationship, but it has condition to do this. Okay, so that's the major concepts in this chapter. Okay, later on we are going to discuss coding examples. They have a better idea. Okay, so the previous national park that we saw in our slides, it's the Grand Teton National Park. Okay, it's a very beautiful national park. Okay, so that's all for this lecture. See you.